The organization of a nursery site should be done with considerable care and forethought to maximize efficiency of production and to minimize loss of time. Some thought should also be given to future expansion and ways of attaining long-range goals. A detailed planimetric map of the site locating all existing facilities, natural or man-made, should be developed. Then, with the aid of overlays, plans can be made to develop the site, including the location of production areas, irrigation facilities, shipping, receiving, storage areas, administrative headquarters, residences, circulation and parking, windbreaks, and beautification. A separate overlay should be made diagramming the location of all underground utilities, including depths, location of valves, etc. A computer with appropriate software is a valuable tool for this process. I'm Dr. DeBusk, and this video will cover the organization of the nursery site, including the areas of an inner nursery site, planting designs, and economic and cultural considerations. The actual size and location of the individual units within the nursery will vary with the size and type of the operation, topography, soil type, cultural practices, equipment and extent of mechanization, availability of labor, and various economic factors. The best sites in a field production nursery should be allocated to the production areas because soil is one of the major production assets. When possible, irrigation facilities should be centrally located within the production area to minimize the length of main lines and laterals. Shipping, receiving, storage facilities are best located at a site that will be easily accessible from a major highway. The area should include adequate parking and turnaround areas, elevated docks, adequate assembly areas, and restroom facilities for employees and truck drivers. The administrative headquarters should be located to provide centralized access to production, shipping, and sales areas without impeding their operation. Circulation and parking are important considerations in the development of nurseries and garden centers. Access and parking for customers should be made as easy and as convenient as possible. Preferably, these facilities should be blacktopped. Roads to the shipping, receiving, storage areas should be readily accessible, about 30 foot in width, with no sharp angle turns to provide easy access for large vehicles. Roads within the production area can be of crushed stone or gravel and between 20 to 30 feet in width, and the gravel area combined to a 12 to 15 foot strip in the center. Windbreaks, if used, are planted on the windward side of seed beds and young transplant areas to reduce the dehydrating, eroding, and abusive effects of strong winds. If windbreaks are planted, avoid species that are known to be an alternate or primary host to a disease or insect that is a pest of nursery crops. Two good uses of evergreen plantings in a nursery are for protecting outdoor propagation areas with sheared hedges and the screening of storage room walls from the heating rays of the sun. In developing the overall plan for the nursery, consideration must also be given to constructing storage areas for equipment, tools, fertilizers, pesticides, and other materials. Container production nurseries will need storage areas for the basic ingredients of their growing media, a holding area for containers, areas for mixing growing media and the production of compost, and special storage tanks for fertilizer concentrate. Attractive employee facilities such as parking areas, locker rooms, lunchrooms, restroom facilities, and office space should be carefully planned and properly constructed and maintained. Clean, neat, and landscaped facilities for employees are important in maintaining morale, which will have a direct effect upon production efficiency. Public areas of the nursery should be planned and landscaped. Mature, well-maintained specimen plants can be developed into attractive planting, which will aid in selling smaller nursery plants. Careful consideration should be given to the nursery's entrance signage. It should be easily read from the highway, professional, attractive, and include current information. This area provides a nursery customer's first impression and is significant. Production areas of nurseries include propagation greenhouses, seed beds, cold frames, liner beds, and the blocks or container yards. In most nurseries, production is centered on one farm, but in large nurseries, production is often distributed over a number of farms. When a nursery offers a diverse product mix, it is desirable to organize the production effort either by method of production, field versus container, or by plant type, herbaceous versus woody, evergreen versus deciduous, trees versus shrubs versus ground covers, etc. When a number of farms are utilized, it is good management to concentrate compatible plant types onto one farm to gain production efficiency. Seedbed areas are best situated on level, well-drained sandy loam or silty loam sites with a moderate level of nutrition and the pH appropriate to the crop. The beds should be oriented in an east-west direction if a lath is to be employed for shade, so that the lath strips will be oriented in a north-south direction. This orientation produces a moving sunshade pattern during bright sunny days, which will prevent sun scalding of the seedling or newly rooted cuttings beneath, which could result if the lath strips were oriented in the east-west direction. The width of the seed beds is generally determined by the width of the equipment used in working the area. The wheels of all heavy equipment widths are 36, 42, and 48 inches. Prior to planting, it is highly desirable to obtain a soil analysis to determine levels of nutrients and presence or absence of nematodes. In many situations, it is also desirable to fumigate or sterilize the soil prior to planting to ensure freedom from diseases, weeds, and other pests. Liner beds are areas of the nursery where young plants are grown under intensive culture for a period of 1 to 2 years prior to planting, either in the field or in containers. The liner beds may be open fields exposed to the elements, or they may be protected by shade houses. Shade houses are utilized to temper the climate to produce better quality plants for transplanting. Plantings in the liner bed are either in beds or in long, narrowly spaced rows. Spacings of 3, 4, 5, and 6 inches between rows are common. The actual spacing in the rows is determined by species, growth rate, and desired size of the transplants. A 100-foot liner bed, 42 inches wide, planted to 8 5-inch rows with plants 4 inches in the row, would support a population of 2,520 plants. Prior to planting liner areas, the land must be properly prepared, including plowing, disking, leveling, pre-plant pest control applications, and subsoiling if necessary to a depth of at least 6 inches. Moisture is critical in this intensive production area. Therefore, a readily available source of good quality water is essential. Field production areas of large nurseries may consist of one or more farms. Each farm is subdivided into blocks and rows. For ease of management, some form of designation is assigned, generally letters for the blocks and numbers for the rows. 2 standard systems are used for labeling plant material within production nurseries. In propagation beds, small field production areas, and in container production nurseries, the most common method of labeling is from left to right and from front to rear. In large field production nurseries, especially when planting is done mechanically, the labeling system conforms to the direction in which the rows were planted. The organization or design of nursery production areas varies from area to area of the country and from nursery to nursery. The determining factor in organizing production areas should be production efficiency. The row is the oldest and simplest method of planting nursery stock on level terrain. The row is used primarily in the production of bare root plants such as herbaceous perennials, roses, shrubs, and small diameter trees. The spacing between rows is determined by the width of equipment used in planting, maintaining, and harvesting the crops. The standard width between nursery rows in many field production nurseries is 42 inches, but this is modified to fit production methods. Long nursery rows can be planted, cultivated, and harvested much more efficiently than a series of short rows because less time is spent in turning around at the end of the rows. The square design is commonly used for the field production of balled and burlapped materials such as large trees and specimen evergreens. It is also used extensively in the placement of containers within the beds of container production nurseries. It allows for cross-cultivation in the maintenance of field production nurseries and lends itself to harvesting on the diagonal for thinning of the field block or container bed when harvesting a crop of small plants for early market. The square design is used where land costs are relatively low because it efficiently utilizes only 78% of the land, but this disadvantage is partially compensated by its advantages. The offset square is used in some nurseries. This is where the plants in even number rows are offset between the plants in the odd number rows. This system gains little advantage over the square and sacrifices the advantage of cross-cultivation and harvesting on the diagonal. It is used sometimes when planning a marketing program incorporating 3 harvest dates. Every other row is dug initially, followed a year later by every other plant in the remaining rows, and finally the widely spaced plants are harvested. In the rectangular design, the distance between rows is greater than the distance in the row. It is the least efficient in space utilization, less than 78% used, but it is employed where land is relatively inexpensive or where larger mechanical equipment is utilized in maintaining or harvesting operations. Modification of the rectangular design is the rectangle-square system. It is used to decrease loss of space, but it still allows for the movement of large digging equipment between every two double rows. Another modification is the interplanting system, employed where wide spacing is used for a long-term crop. In this system, a short-term crop is interplanted to gain a quick cash return. However, it has the disadvantage of different cultural requirements, and if not properly cared for and harvested on time, it can lead to problems in management. The equilateral triangle hexagon design should be used when it is desired to maximize the utilization of space. It is most commonly used in container production nurseries where land is expensive and maximum production per unit area is desired, but it can also be used in field production areas where land is expensive. In this design, 91% of the space is utilized when the plants reach their maximum size. The rows are offset from the square, but the between the row distance is 15% less than the spacing between plants in the row. However, plants in the ground cannot be cross-cultivated, and harvesting time is critical if the loss in plant quality from crowding is to be avoided. The physical organization of the plantings within a nursery will vary with the situation, but the following economic and cultural factors should be considered. The efficient use of land. The equilateral triangle produces the most efficient use of space. The square rectangle is the least efficient. The size of the plant for the market objective. If the market objective is for small plants, the spacing can be relatively close. But if the objective is to produce large landscape-sized plants, the spacing must be wide to accommodate the crown of the plant. The cultivar. If the cultivar has a narrow upright habit of growth, the spacing can be close, whereas if the cultivar is wide-spreading or of a weeping habit, the spacing must be wider. Equipment use in maintaining and harvesting. With modern equipment of high horsepower, it is necessary to increase the spacing between the rows to permit entry and movement of the equipment, especially at the time of harvest. Economic return on investment. Although many agricultural enterprises, including container production nurseries, measure return on investment per acre of land, it is more appropriate for a field production nursery to evaluate a total production system, including land, spacing, maintenance, and harvesting, to maximize return on total investment, not only on land. In conclusion, hopefully you learned how consideration needs to be taken in the design and placement of each area, as well as how to arrange the plants to be the most cost-effective.